Okay, I force-fed you the sum of an arithmetic series. Now I'm going to show you the sum Sn of a geometric series up to the nth term. Let's just write this down first. The nth term is a sub 1 times r to the n minus 1. Okay. The trick is to multiply by r and subtract, and most of the terms cancel. Also note, I'm going to line up the terms under the terms that cancel with them, so. So r times Sn, terrible r, equals A1r. I'm going to write it again under the other A1r, even though it came from just plain A1. This would be A1r squared. This would stick out into space as A1 times r to the n minus 1. If we subtract, we have Sn minus r times Sn is A1. Everything in the middle cancels. And then we just have minus A1 times r to the n minus 1. So I'm going to factor out Sn from the left side. And I'm going to factor out A1 on the right. So I have okay. So my first variation is Sn is A1 times 1 minus r to the n, which will be negative if r is bigger than 1, positive if r is less than 1. So I'm not going to worry about which direction to make things go. Okay. The nth term is the first term times r to the n minus 1. So an times r is going to be a1 times r to the n. So if I look at my Sn, I hate it when it straightens my lines, curves out. If I distribute the a1 back, oh, that second thing is what I just wrote. It's not just an, it's an times r. So we have two formulas. Let me So just like with arithmetic, we have two sum formulas for the arithmetic. We have two versions for the geometric. so the second version is useful if you have the last number. First version is useful, let's see, if you don't have the last number and you don't want to bother. You do need to know how many terms there are. Okay, so if I have sigma notation, it's easy to find the number of terms, and it's easy enough to find everything, actually. N is 9 minus 4 plus 1 is 6. A sub beginning is, and I notate, again, I notate it as A sub 1 even though K is 4, but whatever. Calculator says this is positive 48. And this one is negative 1,536. I told you, these numbers get very large very fast. R is negative 2, because it's the base of the exponent. So let me just highlight that. If you have it in sum form, it's A times R to the K is what you have. All right, so Sn is A1 minus AN times R over 1 minus R. That's maybe the slightly easier one to do with parentheses. Be careful with your minus signs. Strongly suggest putting negative numbers in parentheses. And then you need to either use extra, when you're typing it in, type it in with parentheses around the top and parentheses around the bottom, or simplify the top and bottom separately. Either way, make sure you type this in Okay, so the sum formula on this is even more susceptible to bad parentheses than the arithmetic one. This one, I'm given R and N, so I'm just going to use the other version. So be careful with that. Again, type in the numbers, watch the parentheses, because if you don't simplify things, you at least have to put the parentheses around the bottom. The multiplication gives you an order of operations advantage here, so you don't need extra parentheses on the top. Okay, what is R? Cancel. 8 over 40 is 1/5. So I'm given AN, so okay. And again, you will need parentheses to type it in properly. Okay, the numbers decrease rapidly, so you don't actually, it looks like it's approaching 5,000. I wonder if that's possible. Yes, it is. Okay. So I've given N, so I'm going to use this version. And I'm given Sn. What do I need to find? Oh, I need to find A1. Good thing I know everything else. Okay, so 381 is A1 times positive 127. Is it nice? Yes, it is. Yay.